Let's solve a calculus problem involving finding points where the tangent line is perpendicular to the x-axis. Our curve is y equals x squared plus the square root of 1 minus x squared. Let's break this down step by step. First, recall that when a tangent line is perpendicular to the x-axis, its slope must be infinite. This means that the derivative dy slash dx equals infinity at these points. To find these points, we need to first find the derivative of our function. Let's use the chain rule to differentiate y equals x squared plus the square root of 1 minus x squared. The derivative of x squared is simply 2x. For the square root term, we use the chain rule. The derivative of square root of u is 1 over 2 square root of u times the derivative of u. In this case, u is 1 minus x squared, and its derivative is negative 2x. Let's simplify this expression. We can factor out 2x, and then combine the terms under a common denominator. For the derivative to be infinite, the denominator must be 0. This means that square root of 1 minus x squared equals 0. Solving this equation, square root of 1 minus x squared equals 0 means 1 minus x squared equals 0, which means x squared equals 1. Therefore, x equals plus or minus 1. Now that we have our x values, let's find the corresponding y values by plugging x equals plus or minus 1 back into our original equation. Let's visualize these points on a graph. Here's our curve, and the points we found are at 1, 1 and dash 1, 1. At these points, you can see that the tangent lines are indeed perpendicular to the x-axis. Therefore, the points where the tangent line is perpendicular to the x-axis are dash 1, 1 and 1, 1. At these points, the derivative is undefined, and the tangent lines are vertical.